Hey guys, in this lesson we would understand how to graph quadratic equations using step pattern. Step pattern is a shortcut way of graphing quadratic equations when they are given in vertex form. In one of the previous lessons we have already understood how to graph quadratic equations using table of values. However, making table of values is a long process. We can use step pattern instead to make a graph of quadratic equation in vertex form, and this process is a very short process of making a graph of a quadratic equation. Before graphing quadratic equations using step pattern, we should know few important things. First thing that we need to know is that the equation has to be in vertex form only for this case as well. Second important thing is it is a fastest way to make a graph of quadratic equation in vertex form. And the third important thing we need to remember is understanding properties of quadratic relations from its vertex form. Let's go over an example. Let's say we are given a question y is equal to 2x minus 1 whole square plus k. The first thing we have to do is write down the a, h, and k from the given equation. We have a as 2, h as 1, and k as 2. So the first important property is we can get from the a sign. In this question, a is positive. Therefore, the property that we can get from the sign of a is that this graph is going to open upwards. Next property that we can get from these values is h comma k represent a point called vertex of the graph. We know that whenever we make a graph of a parabola or a quadratic equation, it would look like this, and the graph will always have a tip. So every parabolic graph is always going to have a tip. That tip is going to be called the vertex of the graph. And whenever the equation is given in vertex form, then h comma k is what is this vertex point going to be represented as. In this particular example, h is 1 and k is 2. Therefore, the vertex is 1 comma 2, where 1 is the x coordinate of this vertex point and 2 is the y coordinate of this vertex point. Another property that we get from AHK or from the vertex form is the axis of symmetry. Axis of symmetry is the line that divides this parabola into two equal halves. Always remember, a parabola is going to have a vertex and a parabola is always going to have an axis of symmetry too. This axis of symmetry can be taken from the h value of the equation. So since h is 1, the axis of symmetry is represented as an equation of the vertical line that passes through the graph right in the middle of graph. So we write it down as an equation that is x equal to 1 in this particular example is the axis of symmetry. So always remember, axis of symmetry is written as an equation of the vertical line that passes through the graph right in the middle of the graph. And you have learned in the previous grades that vertical line equation is represented with x equal to the value of the x coordinate through which the graph is passing. And in this particular case, in vertex form of quadratic equation, x equal to h is the general equation of axis of symmetry. So whatever will be the h value, we would write on that equal to x, and that will give us the axis of symmetry for that particular question. These three properties are important properties to understand before we make a graph. After we make a graph, we can also write on more properties looking into the graph that we would discuss after we learn how to make a graph using step pattern. So let's use the same example to make the graph. And the example we have is y equal to 2x minus 1 whole square plus 2. So for step pattern, we need to know the following steps in order to make it into a graph. Step 1 is mark the vertex of your graph on the grid. Since we know in this example vertex is 1, 2, because vertex is h comma k, so we would mark point 1, 2, which is here as the vertex of the graph. Step 2 is we use the step pattern 1a, 3a, 5a, 7a, and so on. Whatever number of points required, we can use just 2 of these points, or we can use 3 of the points, or we can use 4 of the points to obtain points on the parabola. In this particular example, we have a as 2. So the points on the parabola would be 1a is 1 times 2, which is 2. 3a is 3 times 2, and that is equal to 6. 5a is 5 times 2, and that is equal to 10. Now remember, these 1a, 3a, and 5a, they represent rise over run. So 1a is going to give us rise over run. Similarly, 3a is also going to give us rise over run, and 5a is also going to give us rise over run. So 1a value we have is 2, which is when equal to rise over run, means rise is 2, run is 1. Here rise is 6, run is 1 again. Here rise is 10, run is 1. Now we'll apply these rise over runs on the given point. When we look at the grid, we see the first point is the vertex, that is 1, 2. We have already marked it. 1, 2, that's the vertex. Now the first point after the vertex is going to be decided by the first rise over run. And the first rise over run is 1a, that is 2 over 1. So from this vertex point, we have run 1 and rise 2. Because the parabolas are symmetrical graphs, whatever we do on the right side, the same thing we do on the left side as well. So from this vertex, we again run 1 on the left side and we rise 2. The next rise over run comes from 3a, and 3a value is 6 over 1. Therefore, the next rise is going to be 6. Run is going to be 1. From this right point, we go run 1 and rise 6. 4 plus 6 gives us 10. And from the left point, we run 1, rise 6 again. So we reach here. We need not even use 5a and 7a in this case, because we have enough points to join in order to make it look like a parabola. This is how the parabola would look like when we join all the points. So from the vertex, we run 1, we rise 2. From this point, we run 1, we rise 6. And we do the same thing on the left side. Run 1, rise 2. Then we run 1 and rise 6. And we see we get a symmetrical parabola. This is how we use a step pattern to turn a vertex form of quadratic equation into a graph. Let's take another example to turn the vertex quadratic equation into a graph. And after we've done that example, then we would take up the rest of the properties from the new graph in order to understand more properties of the quadratic equation graphs. Let's say we have a question y equal to 1 over 2 x minus 3 whole square, and we have to turn this into a graph using step pattern. We know a value is half, h is 3, and k is not there, means k is 0. First step is we write on the vertex. Since the vertex is h comma k, so it's going to be 3 comma 0. Second step is to write on the step pattern, and the step pattern is 1a, 3a, 5a. 1a means 1 times a is half here. 3a means 3 times half. 5a means 5 times half. So this would give us 1 over 2, 3 over 2, and 5 over 2. Now let's make a grid. So step 1 is we mark the vertex, that is 3 comma 0. So we have x is 3, y is 0. So this is our vertex. Next we have 1a, that gives us 1 over 2. So rise is 1, run is 2. Therefore from this point we rise 1 and we run 2. That means we run 2 on the right side. So from 3 we reach 5 and then we rise 1. This is where we reach. Similarly on the left side we run 2 and we rise 1. And this is where we reach. Next we have is 3 over 2. So from the previous point we run 2. Therefore we reach from 5 to 7. But we don't mark a point here because we still have to rise. And the rise here is 3. So from 7 we rise 3 and we reach 4. On this side as well, we run 2, we reach here and we rise 3. And this is where we reach. If we still want to keep going, we run 2, we rise 5. Run 2 means we go from 7 to 9 on the x-axis, and rise 5 means on the y-axis we are at 4, so we would rise by 5 units. That is, we would reach 9. Similarly here, we run 2, we rise 5. And now all we have to do is just connect the points. And this is how the parabola looks like. Now let's write down the rest of the properties. The first property we got is the vertex, and that is vertex is 3, 0. Second property we need is axis of symmetry. We can write it as an acronym AOS. We write on axis of symmetry as an equation in the form of x equal to, so this is our axis of symmetry. It's the line passing through right in the middle of the graph, and it would be represented with x equal to the h value. H value is 3, so we can write on x equal to 3 as the axis of symmetry. Next property, third property is, because a is positive, so we notice that the graph opens upwards. Next property is stretch or compression factor. Stretch or compression factor always comes from the a value again. If a is greater than 1, then it is a stretch factor. That's why it's called vertically stretched. If a is in between 0 and 1, then it is called compression factor. So here we have a compression factor because the a value given to us is half. So compression factor of half. And then the final property that is very important is the values that x may take and the values that y may take. Always remember, whenever we are making a graph of a parabola, the x value that the graph can take is any real number, because this graph is never ending graph, and if we extend this graph, this is going to keep on extending both on left and the right sides. So the x values that the graph may take is all real numbers. And the values that y may take is, when we look at the graph, this graph is never going to go below the x-axis. It's always going to keep going above the x-axis because the graph is opening upwards. So the values that y may take is all real numbers greater than 0, because the first y value that we would see on the graph is 0, and after that it keeps on going up. So this is all real numbers greater than 0. Now we can even get these values that x may take or values that y may take from the equation itself. And how do we get it from the equation? We know the equation that we have is y equal to half x minus 3 whole square. Because k is 0, we can put it as plus 0. So in order to find out the values that y may take, it will always be taken up from the k value. And whether we are going to write on greater than or less than, that depends upon the a value. If a is positive, then values y may take is greater than k. However, if a is negative, then values y may take is less than k. For values that x may take, it is always the same answer, that is all real numbers. And this is how we make a graph using step pattern, as well as how we write on the properties of the given equation in vertex form or of the graph of quadratic equation given in vertex form.